afternoon. Sir, good afternoon.
Good afternoon,
Good
sir.
afternoon, sir. Good afternoon. So I'm audible. I'm sharing a screen just to confirm whether you can see the screen. Yes, sir. Yes. Yes. You can see this clearly. Yes, sir. Visible. Okay. So I'm discussing and just there to discuss two of the relevant and practical problem with you. Okay. And this is a part of the curriculum and the IBC course. So we have two sessions on right now and next week tomorrow. So we will discuss the concepts, what is the concept behind that, and the purpose of the training. And one question can be asked among these two problems. I think that is easy to answer. You need not worry about the exams. There's not very difficult exam. It's very simple. All your standards. You all are educated. It's not basic, but only problem is that you should know the concept behind this. I hope you have understood the theory part very well. So, in the practicals, you have to know the concept, how we can visualize these things practically in the charts. What are the things? One is that concept that we take. One first problem is that you have to understand the concept of divergence or the convergence, whatever you say, and vorticity at any point of the streamline. Okay, this is one. Today we will discuss this, and the second tomorrow we will discuss how to find the geostrophic wind and thermal wind. You don't have just vorticity medium sometimes. It is what advanced level, but geostrophic wind calculation nominally means their values to the point of concentration north, south, east, west, they will be value of CPM geopotential height of any level A will be evaluated. We have to calculate geostrophic wind and thermal reduction between the two layers. Thermal wind. So I hope you people have understood this concept very well, but I will give you a brief introduction also about many of that. These two problems will be discussed in 2 days. And the limitation will be on the online limitation they will only hear it. And I will make sure that as much as possible you can understand the concepts. And we focus on the concept. Don't panic yourself for exams. Your geology exams are not important and geology concepts are important. They are really relevant while working on stations, while working in the airports, while working at other sectors, the mental health sections. These are not concepts, regular concepts which are taught in schools and colleges. Okay, you have been taught something else, only this is applied science. Understand the science behind that, what is the fundamental of any science. First of all, we will discuss divergence in vorticity. Okay, so can you hear me now? I am audible? Yes, sir. Okay. You are free to ask questions if you can understand things. You can ask if you have confusion. Free to ask. So, first of all, let's understand. Here, many things are written. Most important thing is streamline. You need to understand what is streamline. I think in theory class, somebody has really told you what is streamline. Streamline is some 2D chart. 2D chart, two-dimensional chart where winds are plotted. What are the plotting of the wind? One is that its direction, second is its swelling. How much swelling, how much not, 5 knot, 10 knot, 15 knot, 20 knot, etc. So these two values have two different analysis. One is streamline. It is the flow of the wind which is telling you the direction. Means it is telling you the direction. If you draw a line, that is known as streamline. So streamline, by looking at streamline, you can assume that the wind is flowing like this. Okay? It is then going inside the lower area, it's coming outside from that is cyclone, other is creating breeze, creating many features. And second part is speed. Speed analysis is known as isotag. Isotag means speed analysis. This is separate thing. Directions are separate and the speed is separate. So it is never the same. If two analyses are done together to have a different isolines. Okay, practically. Okay. So this is the purpose to understand from a practically analyzed chart of the stream. So I'm just giving you an example of statement. After going for the examples, you will understand more. But first of all, listen to the concept. Then comes the vorticity and turbulence. So why did we what is the vorticity and turbulence in the geology, especially for India? So I will tell why we what is the importance of vorticity and turbulence? Any consent? How many people have joined? May I know it? Numbers?
Sir, two are left only.
So I will tell you the basic concept. You should have a concept that will work for you. Because this is a reproductive training, a very important training, the building block of your geology knowledge. So understand that our atmosphere has two types. Okay? Meteorologically, it has two types. One is baroclinic, one is barotropic. Okay? What is baroclinic? What is barotropic? Our country is in tropics, so our atmosphere is barotropic. Barotropic atmosphere from down to upper level up to 100 millibar HPA. You will see that atmosphere is divided into the pressures. And pressure and temperature are in the same lines. There is no separate temperature gradient. Only the atmosphere is divided by the pressure level. And in that pressure level, temperature is also divided to the pressure. These type of atmosphere is known as barotropic. But whenever we go to the mid-latitude, so we see that there is a temperature difference between the different air masses. So different air masses have a different isotherms. So isotherms started cutting their isobars. So these type of atmosphere is known as baroclinic. Their concepts are different in our barotropic conception. So because we don't have baroclinic atmosphere, so what is the asking value for us to understand the atmosphere? It is the vorticity and the depth. Means in atmosphere, if some flow is there, whether this flow, what can it do? Either it will have a steady start, okay, like you understand it is like a flow dynamics. You start seeing it like a river. River is flowing, there is some hurdle. You see the same level in atmosphere, they are the pressure heights. One is range and trust. There's like a valley, is there like a mountains, there like a hillocks. Pressure structures are there. That is why we study contour charts. Contour chart different heights of geolocation, the height of different air are different. That is why it is. You can say that air elevation produce certain certain you can say vortices, and that spin is known as vorticity. So here you can see the definition. It is a measure of the total spin of a portion of a fluid. And what is divergence? Divergence is a measure of the portion, but you want to understand, but you understand. whether it is expanding or is it contracting. If it is expanding, then it is divergence. If it is contracting, it is convergence. Why? Why the name itself is very much clear that the divergence means things are expanding. Convergence means converging to a thought. Not level you say that your thoughts are very converging thought. So these thoughts are like this it itself is very clear. Okay? So these are the two concepts we want of the total flow. When the total flow, if you go for the general separation over the earth, you should read this thing and probably they are going to probably also they are going because I have the training, so I feel over the road is no east and west direction going in the so general circulation is mostly the chunal. So whenever these roads happen, there is a cyclogenesis in between. That cyclogenesis creates weather. And known as the ocean area. It is over the sea, and it supports very well on the condition like thermodynamics is supporting, and then it becomes cyclone. What is cyclone? Cyclone is a strong motion system which is spinning over area. God will have moisture will be like over the sea. Thermodynamics is also playing a role. Upper air divergence, lower level convergence, and it's a start getting like a boundary picture. Thousands of thunderstorms, raging heavy. So this is like same is like in small scale. It is on the land is known as propulsion. Then sometimes it can accelerate or you can say that it becomes depression. There are criteria for these definement areas and over the social is concerned, there should be close response. More than two, there is depression and it is also between certain range to play and as well as moving categories. So I think we should have overcome this. So what my our aim is to understand dynamically how to calculate this. If you have the our concept, then you can apply it when you analyze the chart. And this is also a basic you can say alphabet for and the looping. What the weather prediction? What the weather prediction works on dynamic mechanisms. Because it is nothing but you are deriving the wind. What do you understand by anything in this dynamic map that wind flows because of the pressure gradient of the two areas over why is pressure gradient? Because of the sun's heating of the sun, there creates a different thermal gradient where thermal gradient creates pressure gradient. And because of the pressure gradient, it starts flowing over there. It will go to the high pressure, low pressure, but Earth is rotating, so there are other forces also. And started relying on that balances are known as geostrophic balances. Okay, let's see further. So these are the electricity and levels are derived. Once you know the wind flow, you understand the wind flow, then you start understanding these concepts. These are the derived concepts. So you should have. I will not go much into detail because it is a part of theory. Okay, divergence is given by this formula G2 whatever U by delta x plus over V by delta y. This is a simplified formula. And if it is a negative, then is a divergence is a positive. So the negative divergence is convergence. Anything is negative. Actually, term is divergence. If it is a negative, same concept is same. So let's discuss vorticity. Vorticity and initially you have understood the global string of the fluid. But it is a vector del cross V. And what is the evolution? Del dot V.
System
Total one is scalar. Del
System.
cos p represents the
Slope.
curl of the vector of the negative. Meaning vectors are curl of the del cos p. Del cos p means it has a three dimension. But we are only interested in only one dimension that produces horizontal and vertical movement. We are not interested in other dimensions. Okay? But how it is vertically, horizontally moving, we don't want this. We only want to know that by U and V, what is the effect on Z? Okay, please make sure you are only want to understand the effect of in the Z direction. That means vertically, whether air is sinking or air is rising. You are more interested in this. That is why in learning physiology, if you further read further and you go for advanced, there is approximations of things and very mechanisms. Obesity had a very long equation. There are four terms. Each term work in the different conditions. So once you should go for advanced, then you will tell this happens. Right now, because of scarcity of time, let's focus on this. So rotation in XY plane gives rise to the vertical motion, which is upward or downwards. Okay, divergence produce downward motion. Okay, convergence produce upward motion. These should be very clear. We need not to put much weight in should be remember. Okay, in northern hemisphere, anti-clockwise rotation is there. What you call it? Is a positive rotation. It is a cyclic. And the clockwise actually there is a downward motion smaller and the circular moves. Okay, negative moves. That means it's negative. So this concept of cyclic obesity as well as you should not mix this concept. These are separate concepts. You should remember this. Cyclonic obesity in northern hemisphere will be going clockwise. Means it is low pressure area. So what will be the direction? Direction will be upward. So it will be if it is the right hand clockwise, then there will be a sinking motion. Subsidence we call it. Okay. Then vertical component after लिखा है theta is equal to this. We are only interested in this. Then v by w x minus w by 2 by y. This is our simplified equation. For you, this much is okay. You understand the concept. Try to understand the concept. You ask me the question if you want to understand the concept. Because it is derived from the long equation and it is not a part of practicals. Okay, you understand what is natural coordinates. Anybody knows what is natural coordinate? You are at the end of the training. Shall I expect you to know natural coordinates? What is natural coordinates? Why it is being chosen? Any idea? No sir, we chalega, we can no sir. I know we're not telling yes sir, but you will say yes. No sir. Okay. What is the natural coordinate? Natural coordinate system is used in the ranking for plotting for our ease. Why? Because in the Cartesian coordinate, you have defined the surface in xy plane or z plane. Okay, but Earth is spheroid. It is not a flat plane. So the z axis keep changing when you move upward in like two ways. So if you have a low EU classroom, you put one pin for the equator, then you put one at 30 degree, one for 45 degree. Each pin will be in a different direction. Zenith will change. Okay. And if zenith will change, how many connection coordinate can be? So we have this system known as tangential coordinate system, is also known as natural coordinate system. It has a very simple principle that wherever on the earth, you take three vectors T and K. What are three values. One is the movement of the wind to its particular to left and behind, but always over the points there will be K and zero value. So wherever there is a value, you apply these. So the spherical property of the earth can this can be automatically visualized anywhere that it will give you x, y, and you don't have to give the negative value, positive value, this, that, you don't have anywhere the wind left side is and the upward side. Okay, so this is one of natural coordinates. It is derived in the because of the earth spherical because winds are going on high. They are going from equator to the poles different ways. There are the Madonna flow, there are the lunar flows. How to rate it? That's what I'm interested in. Okay, next. Okay, this is a very simple formula which we will discuss. Okay, what is this formula for this? Averages VTN plus del delta V by delta S second per second. Okay. So there are two concepts. Same in vorticity VKS minus delta V. So what is KN? There is some writing. Yeah, but what is not there? There is a lots of dhatu. Everything is okay. I'm talking to myself now. Anybody is there? Listen to me. Yes, sir. Okay. So listening now. Just please say yes, no, something.
Yes, sir.
Okay. I'm talking to myself. So this is the divergence formula. The divergence formula. The basic thing you need to understand that it has Kn and Ks. V is the wind speed and any contact position. You're calculating it, you should know the wind. Then see, what is Kn? Kn is the orthogonal curve of the normal to the streamline. So what is orthogonality? Orthogonality, anybody knows? Orthogonality, okay. Orthogonality means in any curve, you put a perpendicular to the each streamline. Okay? There are 3 to 4 streamlines. You put a perpendicular to the curve, and if you join them, there will be a new curve that is known as orthogonal curve. So you should know this orthogonality of the streamlines. This is here. And what is here is a streamline curvature. Okay? And what is this? LV by L should have only later change of wind speed around the streamline in divergence. And del V by del L is a shear term. What is a shear term? Anybody knows? What is shear? The idea of shear?
No, sir.
No idea?
No idea.
Shear means, I will give you the example of jet stream. In jet stream, there is a main flow where is a maximum wind speed is there. But as you move vertically and horizontally on that flow, your wind speed will decrease. Along the horizontal movement also it will decrease. There is a increase there. Wind will be 30 knots, 40, 50, 60, become 100, horizontally. Then it will become 80, 60, 30. This is the horizontal shear, and there is a vertical shear. There is also shear along. You can say that the pole is there. In the left hand side, you will see there is a wind speed decreasing to the left, wind speed decreasing to the right. And these two, these are the wind speed will be have a different value. It is not in the symmetrical value. So in any atmosphere, the shear along those wind doesn't have a symmetrical value. It can be anything. But you should understand there is a shear terms. There is a change of wind speed that right in the streamline curve. If you know this is not a shear curve. So if you know the streamline curvature, how streamline is a curvature, how you know curvature, I will show you the curvature grid. But don't go for that, just understand how the things are bending. It is not straight line, it is bending. The left to right, anything. In low pressure area, then it's anti-clockwise. High pressure area, it's clockwise. So the bend is known as streamline curvature, and at the point of calculation, what is to the left, what is to the right, what are the value of the wind speed, it will give you shear term. Change of wind speed and direction is the shear. And also we discuss shear terms in aviation, we discuss shear term. Aviation has two things, one is turbulence, one is shear term. So when you go to the airport for working, you will see that these two things are very important for a pilot. One is wind shear. Any flow can produce two things, either turbulence or wind shear. Okay, next is the dimension. What do you want from dimensions? Orthogonal to the normal to streamlines. Means the streamlines are there and you draw a normal to them and you have a orthogonal curve. And that orthogonal curve will tell you the measure of expansion or contraction. Why do you need? You want to know whether this is expanding or is it converging. And what you want is a speed that along the streamline, what is the rate of change? So these two terms are needed in divergence, other two terms are needed in vortices. Okay. So you have to concentrate in this working formula. You need not to go for details, it will take days to understand and it is a very that is a separate lecture. I think you should understand these things. And because we have already gone from theory classes, I must expect that they have told you very beautiful explanation of the theoretical part. Okay. So what is we want to know? One is that orthogonal curve portion. Next is the rate of change of speed. Now the streamline is giving you divergence, it is giving you measure of the expansion of convergence or vorticity that is telling you first of all streamline, how streamline is curving because it's a curl of a wind vector. The streamline is to see the curve, it is important. Itself is if it is straight line, but tell me I don't listen to your words. Let me ask you. If there is a straight line, streamline, what will be vorticity? I'm audible? I'm audible, I'm connected. Hello.
Yes, sir.
So nobody is replying anything. You have taken much of the lunch. अच्छे से खा तो नहीं लिया हाँ खाने के बाद everyone is scared for the bed. Two people are listening from home or at the Chennai. Please pay attention. It's for your use. So let me go fast. I think people are not responding. You have more only listen for community, so I must go. Let's follow. Okay. How to calculate divergence? To any point of concentration, draw orthogonal curve to the point that must be perpendicular to each streamline. I will show you how. And the arrows who shows that the orthogonal curve to the left of the fluid marks a positive or negative its make anti-clockwise. Okay? So these convention you should know. Now I will give the example, then you will understand what it means. Okay? Then what you do, you will take a grid curvature and you will fit that grid on the streamlines and you see what is the value of this orthogonal curve. Then you understand, and then you take the value and put that in formula, and that formula will give you reference. In same way, uh, okay, this is for curvature level. Then secondly, that for the point of concentration, 1 centimeter forward to the streamline, 1 centimeter backward to the rear of the streamline. You should take two values. That is rate of change of wind speed, and that will give you shear current. Okay. So this is Vt minus Vu. When you see this, you will understand divided by 2. Very simple. The scalar factor is 10 from minus 1, so it will become 10 to the power minus 5. Okay. Compute divergence by this method. We will see after that. Then velocity, this equation is there. We use as a statement curvature at a point and how take the shear term from the end. So you put the okay, first of all you have to from seeing this you have to know the curvature value. Then from the left hand side to the right hand side you calculate the value 1 centimeter left and 1 centimeter right. Then this will be the shear term. Okay. And I'll show you how this is calculated. I'll share the PPT, don't worry. You will understand it very easily. So, this is the first example. I will only discuss the example because of already and limited and to explain this on the online is very difficult task because I'm not sure whether you are sleeping or you are really listening from the distance. Okay, these are the three arrows looking like machine. Okay. And in one between one this middle arrow, these are three extreme lines. There is a cross. At this point of concentration, you have to calculate divergence and velocity. So first of all, tell me whether there is any velocity in these three lines. These three lines. Anyone? Is there any velocity terms in these three lines? Yes or no? Are you listening to me? Yeah, many people are there.
Yes, sir.
But nobody is responding. In this three streamlines, there is a velocity term, yes or no? If yes, why? No, why? There is no velocity in this because these trees are lines which is literally parallel to each other. There is no curve. If there is no curvature, streamline curvature, how can you have velocity? So in these lines, only thing which exists is divergence. These practicals are made just because to give you concepts. You should have a concept in daily life when you see information are below, streamlined flow. So it is made so that you should have better concept. So in this part, you see that there are dotted lines known as isotag. So first is a 10K means 10 knots. Second is 20 knots. So it looks that is its outflow. Okay. So it is outflow means things are level. So by a practical outlook, if somebody layman can understand that the three arrows are moving apart, there will be anything possible, it will be divergence. If they are converging, if you put these arrows in the opposite direction, it will show you divergence. It is the sign of arrows put in the left hand side of my left hand side. So it will be divergence. They are diverging, but they are expanding in cities. Okay, what we want to know at a point of consideration, you can see my cursor. Can you see my cursor?
Yes, sir.
Yes, sir.
This is the point of consideration, okay? Then one thing is that we want to draw a orthogonal curve. So for this thin line, we draw a perpendicular, okay, up to many times we take often classes for the COVID. The Dutch one, I think three was offline for the MPI. Many centers are having there. So they are used to ask how to draw this. So this is, I gave you an example that I would put straight lines in between these three. Then you draw, you see that each perpendicular line will be, they will attain this curve. This is an anti-clockwise, means here, okay? So this is anti-clockwise. This show divergence. Always remember, if you go to the left, it will show divergence. Please remember this concept. These are confusing concepts sometimes. It will confuse with the other concepts. Orthogonal curve and normal and cyclonic flow are different. They are C-value. Orthogonal flow is something different. Not within orthogonal curve, but streamline. It is moving towards left. Clockwise means it is divergence. Okay. And what we do that in 1 centimeter and we have a 1 wheel speed that is supposed to be in between we have this cross speed of 15. Example, 1 centimeter and 16, 1 centimeter here is 14. Okay, this you can assume this is only for examples. 1 centimeter and 16, 1 centimeter is 14. So you got this rate of change of along the streamline. So you got two things. On this curve, on this rate of change along this side, these two curves will give you divergence. Okay, let me show you. Can you see now this rate?
Yes, sir.
Yes, sir.
What is this rate? This is a curvature rate. It is a standard curvature rate with a scale. It is designed as a scale. It is also known as railway laws. Sometimes railway also do parliamentary studies, standard shock, use railway curves. Common curves are made because of many factors. This is designed for our purpose. It should be provided you on exams also. Okay, so you can see each curve have a different value. 6.0, this is 1, 5.01, 4.5, 4, 7, and. So you have to put this tracing paper on the curve, on the curve, and you note down the value. Okay, so this will be one down, these ones, and it is the zero of this will be a here. Okay. So remember this curve. I just showed you what is the curve, how to do the value of the. Okay, come back to the problem. So again, in this term you will have two values. Next, just remember this exercise. We will go to the next exercise and we will go to the results. Okay? Yes. Then you understand one more practical. It is very easy. We give you only give you the concept of awareness. But now we have the concept of photosynthesis also. This is the one more exercise. The perfect exercise, but I am discussing it. So you can see that this schematic. Yes, sir. Once again, I should take one. This looks to be a flow procedure. Winds are coming inside a system. Yes. It is very much evident. Everyone can know that this is the streamline and it is coming and coming, and it is coming inside it. It's a low pressure system and low pressure system. So in every clockwise from it is there. It will rise. Okay. Definitely there will be conversions. Yes, sir. Okay. So how to understand the same problem in this? There is also a topic type of curve is there. This is telling you the isotype. Okay? This is variation of isotype. You can see that. So how the wind speed is changing is different than how the wind direction. So this is a point of consideration for you. Suppose I am giving you this. Okay? You can see my concept? Yes, sir. What you have to do first term for divergence, let us go for divergence. Okay? Then for divergence, we will start putting the orthogonal curve creation of that is normal to that you will see that one streamline is this, one streamline is this. Okay? You put the normal and you start putting the normal, one streamline is this. You will see there is a right hand side movement of the orthogonal curve. Okay? You will see the curve in the right hand side. So this is convergence curve. If this is going to the left hand side, in the divergence. If this is going right hand side, convergence. You should remember it very well. So again you put the grid, curvature grid which will be provided to you. Okay, and you can know what is the curvature value. Simple. Curvature value is only trace from that. You put a tracing simple like thing. You understand what is the value if you draw a right curvature. If you are not able to do the right curvature, then it's a failure. And you cannot wrap it out. If you can't draw a straight line and you cannot I suppose that you should do right curves. And it is not that difficult. I don't think it's difficult. Second is that what you want? You want that along the streamline, what will be the wind speed changes. But in the previous case of there are three lines. And I have given you straight two vertical lines as isotack. But in this case, isotack is also the round thing. It is a low pressure area moving like this. So it is not straight. So you will see 1 centimeter ahead here. First of all, you. Then you will see that this is touch. So this is 10 knots. This is 5 knots. This is 15 knots. Okay.
Yes.
So this point is in between 10 to 15. Looks to be around 12. Okay?
Yes.
Now, what the assumption? There we have assumed things. It is not it's only for practical purpose of concept. And if you go to this side, of course, it is just below the 10. Is it 10? Maybe between 10 to 5, it's just below 10. It can be 9. Okay. So it can be 11, it can be 9, it can be there. It's just for concept. Or you can consider the 8 also. Whatever. So we have to know the value along stream. Okay. These two terms we know. These two terms, one we understood the what is the value of curvature, and second is the from the isotype value we can understand one centimeter ahead, 1 centimeter here. What is the value? So our conversion divergence term is very clear. How to understand if the conversion to divergence because of the orthogonal of this going right hand side, it is a convergence. If going left hand side, it will be divergence. And by looking at the image itself, it shows that in the low pressure area where convergence is zero. So these are the clues. Okay, now the time comes for vorticity. What is vorticity? Vorticity is the streamline curvature. So you know the streamline. This is the streamline. So you take the tracing paper and you estimate the curvature. You estimate this curvature by so this term is very easy. Next term is what is the next term? It's a shear term. Shear term means 1 centimeter to the left, 1 centimeter to the right. Okay, so 1 centimeter to the right, it is around 30, roughly 30. 1 centimeter to the left, it is around 6, 7, anything to there. Just so that idea. So you understand the two parts. Divergence, you have orthogonal curve, all orthogonal curve is usually in anti-cyclonic flow, it will move right hand side. In cyclonic flow, it will move left hand side. Sorry, anti-cyclonic move left hand side, anti-cyclonic it will move right hand side. So by knowing these curves, you can understand the divergence of the curve. First of all. Second is that you should understand along the streamline what is the changes, the rate of change will give you shader. Secondly, obviously, you have to know the curvature of the streamline from same grade and the left and the right. You know the wind speed known as shear curves. Change of wind speed to the left. I think that much is clear to all everyone. Now, clear. Should I repeat again? So let's see answers.
Yes.
अब आपको you see answers, you will be happy. Sir, thank you. Oh, thank you. First of all, we'll see divergence. Let's see the divergence. Example A, which we discussed. That is the three lines making the tissue formation. Okay? Suppose there is a difficulty. That exercise. What is the value in the center? If you remember, it was 15 knots. Then it is converted into amperes by multiplying 154 from 8. Okay? And then it will be. So what is the Kn? What is Kn? Orthogonal curve. From that, we show that the value should be 5. Okay? That is why 5 into 10 to the power 6 is written. The value of that blade to be fitted is 5. If you do the practicals, if you are offline, here or somewhere, then if you the sector or teacher or will tell you whether it is right or wrong. From a distance, I can't say. Because you are not making only distinctly. So this will be fine. Okay? So once you apply this, multiply simple multiplication by LC or something you have to put out by from the line. Simple. No, nothing. Next part, PD and PU. Ahead of the streamline, value was 60. Below it was 14. What is the term? Divided by 2.5. Okay. So 0.5 no issues. I don't think it is a very simple mathematics. When you combine these A plus B, then you will get 4.25 transform multiplier. This is the divergence term. It is objective. Okay? Yes. We will discuss next term. Next term, it is value of the temperature. Its value was 10 knots. Okay? It was converted to FPS. Then we draw an orthogonal curve. That curve was right hand side. That is the negative curve. Yes. You will put the value negative. If you have to break curvature on your orthogonal curve, the value should be 7.0. We are giving you simplified values just for the concept. Okay? In real life, it can be anything 7.2, 7.5. You can have multiple calculations. Okay? But for example, because many people cannot understand by this simple example. If we complicate it, then almost out. So, just for simplicity, that curve will be 7.0. What is the 7.0? I again explain. That this curve will be like this, 7.0. And in the first side, it will be like a 5.0. It will match this. Understand this? Have you understood this? Matching of the curve of first will be 5.0 curve. This will match your orthogonal curve. And in the second, it will be 7.0 for your examples. So, then it becomes the value of VPN minus 0.5. And I explained to you that what is the value of the streamline. And that value was between ahead of the streamline because 25 knots was 28. And rear of the streamline was between 10 to 50, between 10 knots to 15 knots is equal. So by that calculation, simple calculation, compensation, we have chosen these values, and then these values are combined A plus B, and you have a negative value minus 4.5 or minus 5. So this is a conversion system. You have calculated the convergence for the second exercise, the divergence for first. Let's see for the multiplicity. So in A, B is 50, according to LPS, but there is no case, no arguments. The line of the the streamline was straight. The streamline was straight, so no multiplicity. Multiplicity, you need a curve. No curve. So we'll go up, set B, second exercise. And then one of the translation will give you a stand, convert it to LPS, then what was KS. When you put that graded curvature on your streamline, that will come 1.5. You have to be on point. If you only put to understand the curvature of streamline, it will be 12.5. Okay? Simple mathematics, 6.25 plus 1.5. It will be converted into equation PKS. And what is the shear term? The left hand side, you have a BL that is between 10 to 5 knot. Okay, that is roughly 7. And to the right hand side, it is coming between the oblique and 10 knots. It is roughly 30 if you remember the correctly, if you are available when you are seeing that, then you calculate the simple formula PL minus VR divided by 2, that is 1.5 plus 5, and when you will have the A minus B value, it is 7.75 into 10 plus minus 5. So this will give you vorticity. But this vorticity is positive. Positive vorticity is always generated from low pressure systems. Converted systems. A system which have a anti-cyclic flow. Okay? This is all are related to each other. So whenever in the future when you will need a discussion, you will have a part of discussion and they will say that there is a velocity there, there is that, remember how I told you how it is applying data. Okay? They are applying by two terms, the Steven curvature, sorry. The Steven curvature is one term that is telling you how the curl of the wind is there, and second is the shear term, how the wind is increasing or decreasing on the both sides. Okay, this will give you example of the circle. So these two exercises you need to understand. I will explain tomorrow. I think already said. So next tomorrow I'm going to take a class in which I will tell you what is the basis first of all, the basic concept, then how it can be calculated from a real-time RSI value data which is from the plate. We fall in the NWP plate. From that data, how can we calculate its specific plate? And secondly, by knowing the two levels, 850 or 750 or 500, how can we know the thermal wind? First of all, it has two parts. One part will be the value, that is the mod part. Mod part means its value, amplitude. What is the value of what? Another will be direction. How to calculate direction? This is also another part. You will have two concepts tomorrow for just the calculation. One is how to know the values, how to the direction. Okay, that much is clear today.
Yes, sir.
Yes, sir.
Then, if any question is there, you can ask me and shall I use?
Yes, sir. Thank you so much.
Thank you very much for listening. Thank you.
Thank you, sir.
Somebody is doing carpentry work also.